Hello everyone. Through this video we are going to discuss question number 1 Roman 3 and Roman 4 of exercise 4.1 in a chapter of practical geometry. In my previous video already we have discussed the first two problems of this question number 1. So today through this video these two sums we are going to discuss. So here is the first question. Parallelogram, actually we need to construct parallelogram MORE where OR is given to be 6 cm, then RE is given to be 4.5 cm and EO is given to be 7.5 cm. Now for our convenience we need to first draw a rough sketch. So suppose I'm drawing OR first. This is OR. Next we are given EO and RE. So of course from this end OR means from this end R we can draw RE. So let this be RE. Then after, since it is EO given, so we can join these two. EO. Already it is told that the figure should be a parallelogram. So if this is a parallelogram, then we must have to note one thing, that the opposite sides should be equal and parallel. So here in this case it is very clear that the other side, I mean the side that should be parallel to OR should be drawn like this, and this side is again parallel to RE. So we can fill it up like this, MORE. So here in this case OR is having measurement 6 cm, then RE is having measurement 4.5 cm, then after EO is having measurement 7.5 cm. So it is very clear from this information that ME should be of measurement 6 cm only, and then MO should be of measurement 4.5 cm. So this is what the rough sketch. This is the rough diagram of this given information. So next we have to draw the main construction, which is the required construction for this question that we have to draw. So I'm going to write here answer given. Let us check what are the things given here. In parallelogram, this term we have to mention here. Given in parallelogram MORE, OR is equal to 6 cm, then RE we are getting to be 4.5 cm, and then after EO we are getting to be 7.5 cm. Let us come to the main construction part now. These values will be required later on. So first of all, again in the main construction part, I am going to draw the line segment OR. I am taking the scale here. The measurement should be 7.5. Sorry, the measurement should be 6 cm. So here in this case, in case of the scale, I shall be taking the gap between two bigger lines. I mean these two lines, say these two lines, this line and this line as 1 centimeter. So if I draw OR, its measurement should be 6 cm. So here suppose I am starting from this position, 1 centimeter, 2 centimeter, then this is 3 centimeter, 4 centimeter, 5, then after 6 centimeter. So up to this we have to consider the measurement. So this is the measurement for OR. Let us mark OR. It's having measurement 6 centimeter. Now we need to draw, next we need to draw RE, what is given here. So taking R as the center and radius 4.5, because RE is 4.5 here. So taking R as the center and radius as 4.5 cm, we shall be drawing an arc here above OR, as we did in the previous sums in my last video. You can go through if you want. So here in this case I shall be taking measurement 4.5. so let's place this. So centimeter wise, this is 1 centimeter, 2 centimeter, 3 centimeter, 4 centimeter, then 4.5 up to here. Up to this mark it is 4.5. So actually this should be the point where I have to draw the arc. So the arc will have to be drawn here. Let us remove the scale. Now actually we do not need this line segment now. We have to remove it. Just to show you the centimeter measurements, I have drawn this line. So this is not needed actually. Just the arc is needed. So I shall be drawing that arc at the extreme end. So here the arc is to be drawn. This is the arc. Please make use of pencil and scale while drawing the arcs. So after that, again to draw EO, what do we have to do? Taking O as the center and radius as 7.5 centimeter, we have to draw the arc to cut this previously existing arc at the point E. So once again I have to consider the scale. So I am going to place the scale here. This is the scale. So checking it, 1 centimeter, 2 centimeter, 3 centimeter, then 4 centimeter, 5 centimeter, then after 6 centimeter, 7 centimeter, 7.5 centimeter, 7.5 centimeter. So here we shall be getting the arc. The arc should be drawn like this to cut the previous arc at this point. So here goes the arc. So the previous arc is cut at this point, and this point will be working as point E. Next, what do we have to do? We have to join this point of intersection with the end points. Like this we have to join. This is the way we can join. Then after, here these two ends I have to join again. So let us join these two ends. Okay, so here is the half of the figure is drawn. It is not yet completed. So to get the construction of a quadrilateral, I mean a parallelogram, we have to proceed with the other part of the parallelogram, I mean other side also. So for that, what do I have to do? Again, taking O as the center and E as the center, another two arcs I have to draw, which will be intersecting each other at another point, say M. Now here this measurement ER will be, ER is given to be, let us check once, ER or RE, the measurement is given to be 4.5. So let us write here 4.5 centimeter. So after this, again taking O as the center and radius equal to 4.5. Already I told you that this quadrilateral is a parallelogram, and parallelogram always have opposite sides as equal sides. So again I have to consider radius 4.5 cm here, and say this is the, I shall be drawing the radius here. So let us check the length. This is 1 centimeter, 2, 3, 4, then 4.5. Let's remove this one and we draw this arc. Now another arc is to be drawn from the point E, taking the radius as 6 centimeter, because opposite sides will have to be equal. That is why another arc we have to consider here of measurement 6 centimeter. Radius should be of measurement 6 centimeter. So let us check at what point it is 6 centimeter. Let us check here. So this is 1 centimeter, 2 centimeter, 3 centimeter, 4 centimeter, 5 centimeter, then after 6 centimeter. So this is 6 centimeter here. So we can draw the arc at this point only to cut the previously existing arc at this point. So this point of intersection is nothing but M, and then we have to join these points. Say E and M will have to be joined like this. It is joined, and then after M and O will have to be joined. M and O will have to be joined like this. Like this will have to be joined, and this is the required parallelogram. With this figure is completed. So this is of measurement 4.5, RE is 4.5. Then after this should be of measurement, EO should be of measurement 7.5. So steps of construction. Let us start with the first step. The first step is what? Let us draw OR is equal to 6 cm. Step number 2, taking capital R as the center and radius 4.5 cm, we draw an arc above OR. Then point number 3, taking O as the center, and radius 7.5 cm, we draw another arc, to cut the previous arc, at what point? At E, of course, at E. Coming to the next step. In the next step, what do I have to do? Let us join OE and RE. Then after we have to come to number 5. Step number 5. Actually there is a correction here. I have to write here EO because already mentioned in the question that it is EO and not OE. So number 5, here I can write, let us draw another arc of another arc of radius 6 centimeter, taking capital E as the center above OR, and to cut this arc at capital M. We draw another arc of radius 4.5 centimeter, taking O as the center, Actually here there lies the explanation of the last step that we have performed in the construction part. Then step 6. The step 6 is, let us join OM and EM. Therefore MORE is the required parallelogram. So with this, construction of the third quadrilateral of this exercise gets over. Then let us come to the next question. The next construction question is what? We have to construct a rhombus BEST, best, where BE is equal to 4.5 cm, then after we get ET is equal to 6 cm. So let us first draw the rough sketch here. BE, of course BE, from this it is very clear that BE stands for the side length, yes or no? Then E and T, these are oppositely lying points, vertices, therefore ET stands for the diagonal and BE stands for the side. We know that in case of a rhombus all the sides are equal and the diagonals intersect each other at 90 degree, bisect each other at 90 degree. So let us first draw the rough sketch of this rhombus here. So say I am drawing BE first, BE, then after it is ES, every side should be of same length, then ES, then after what do I get? TB. So it is BEST. After this I have to draw ET like this. These opposite vertices should be joined. So this is of length 6 centimeter and the side lengths are 4.5 cm. Here also it is 4.5 cm. Then here also it is 4.5 cm. Then again it is 4.5 cm. Now we have to concentrate on the construction of the required rhombus. This is just a rough sketch, so I should write this here. This is rough sketch. So let us come to what are the things given. So in the solution part what I shall write, given in rhombus BEST I get here BE is equal to 4.5 cm, then ET is equal to 6 cm. So after this again I am going to write, since in a rhombus all the sides are equal, hence we shall be writing BE is equal to ES is equal to ST is equal to TB is equal to 4.5 cm, because these measurements will be required for verification. Means all the sides should be equal. So this is, I have given this for general information. If it is not written in the answer part, then also there is no problem. Now the first and foremost thing that we have to proceed with is what? We have to draw two diagonals in case of this rhombus. So first of all I shall be drawing, so let us draw first ET here. So this is of length 6 centimeter. Suppose I am starting with this point, 1 centimeter, 2 centimeter, 3 centimeter, 4 centimeter, then 5 centimeter, then this is 6 centimeter. So after drawing this diagonal, I have to draw here perpendicular bisector. We know that for drawing perpendicular bisector, we have to take a radius of length equal to the half of this entire length of ET or more than that, and then draw, taking E as the center, we have to draw an arc here, then with the same radius, taking T as the center, another arc should be drawn here. Similarly, in the lower part also, taking E as the center with the same radius, another arc should be drawn. Similarly, here also arc should be drawn. Now let us join these 2 points of intersection. We find that actually dotted line should be drawn here. Let us first draw a dotted line, that is the perpendicular bisector of ET. So we have drawn like this. So after this, taking E and T as the centers, we shall be drawing two arcs of length 4.5 cm which intersect at a particular point above ET. So from E, I have to check the measurement at what point the length will be 4.5. For the time being, let us remove this part. This is, if not written, then also there is no problem. We can remove this part. Just for your better understanding, I have given this part, so we can remove this. So after this, I have to take the scale here. So taking the scale from the point E, I shall be taking a measurement of 4.5 centimeter. 4.5 centimeter. Let us check at what point it is 4.5 centimeter. So actually that line should always pass through this point of intersection. So 1 point, 1 centimeter, 2 centimeter, then 3 centimeter. Let us remove this drawing part is not needed. So let us check 1 centimeter, 2 centimeter, 3 centimeter, 4 centimeter. Here in this case I am getting 4.5 centimeter. So I need to draw an arc here. So let us first draw an arc here. At this point I have to draw an arc like this. An arc should be drawn. Again from the point T I have to take the same radius and same arc length I have to take, and radius length of that arc I have to take and cut this arc at the same point. So using scale we can take the length. Let us check at what point it can be cut. The lengths are of course same because it is 4.5 centimeter only. So 1 centimeter, 2 centimeter, 3 centimeter, then after 4 centimeter, and here this is 4.5 centimeter. So we can cut at this point. So an arc can be passed through this. So at this point the arc should be drawn like this. So this is the point at which this can be joined, means I have to consider this point of intersection as B. So using scale we shall be joining this now with this part. Yeah, it is joined. Then after this is joined here. Then after again from this point this has to be joined. So joining, I got this figure. The same process will have to be repeated in the other part also. So let us check in what we can be done. From this part I shall be taking a measurement of 4.5 centimeter, and let us check at what point it will be intersecting the previous perpendicular. Our focus is to cut the perpendicular and nothing else. So 1 centimeter, 2 centimeter, 3 centimeter, 4 centimeter, so 4.5 centimeter. So at this point an arc will have to be drawn. This is the point at which an arc should be drawn. So let us draw the arc here. An arc is drawn. Please use scale and pencil for drawing the arc. So another arc will have to be drawn from this point. Again the scale I have to consider, ruler I have to consider. So taking the ruler here, now let us check at what point this is 4.5 centimeter. Let us check it. 1, 2, 3, 4, of course 4.5 it is here. So this arc will have to be cut at this point. So this another arc will have to be drawn. Another arc is to be drawn at this particular point. So using scale we can join the lines now. At this point I have to join, and then using the scale again I have to draw another line segment showing the sides. So at this point I shall be joining this. So this is the way we can do the construction of this rhombus. So in case of rhombus the basic thing is what? To draw the perpendicular first, perpendicular bisector on the diagonal given. That will bisect the diagonal. Then after we have to take the lengths of the sides given and then cut the newly drawn perpendicular bisector at any point. Means actually the point of intersection of two sides should be on the perpendicular drawn. So this point is E. Sorry, this point is S. So this is how our construction is getting over. Construction steps. Whatever steps we had followed, that will be more clear from this explanation. What is given? We draw diagonal ET is equal to 6 centimeter. Then next one is we bisect ET, drawing a perpendicular a perpendicular bisector at capital M. Let us denote this as M. This is the midpoint here. After this, point number 3, taking capital E and capital T as the centers, we draw two arcs. Of length 4.5 centimeter, which intersect each other at capital B above ET. After that, the same process we had repeated in the lower part of, means below ET also. But taking E and T, taking E and capital T as the centers, we draw two more arcs of radius, plural form is radii always, radii 4.5 centimeter, to cut each other at S, at capital S, below ET. Then after, what do we get? Point number 5. Let us join BE, BT, SE and ST. Therefore, BEST is the required rhombus. And with this exercise gets over. Thank you.